spacecraft. James Clerk Maxwell's equations of electromagnetism hastened the understanding and development of radio communication. A picture on a computer screen can only be created or moved around using a mouse because a great deal of geometrical calculation has gone into designing the software. Nevertheless, there are phenomena which, although governed by the basic laws of science, were historically regarded as too irregular or complex to be described or analyzed using traditional mathematics. Classical geometry concentrated on smooth or regular objects, such as circles, ellipses, cubes, or cones. The calculus, introduced by Newton and Leibniz in the second half of the 17th century, was an ideal tool for analyzing smooth objects and rapidly became so central both in mathematics and science that any attempt to consider irregular objects was sidelined. Indeed, many natural phenomena were overlooked, perhaps deliberately, because their irregularity and complexity made them difficult to describe in a form that was mathematically manageable. It was not until the late 1960s that the study of irregular figures started to develop in a systematic way, largely as a result of efforts by the French-American polymath Benoit Mandelbrot, 1924 to 2010, often referred to as the father of fractals. In his 1982 book, The Fractal Geometry of Nature, he wrote, "Clouds are not spheres. Mountains are not cones. Coastlines are not circles, and bark is not smooth, nor does lightning travel in a straight line." He argued that highly irregular objects should be regarded as commonplace rather than as exceptional, and moreover, that many phenomena across physics, biology, finance, and mathematics have irregularities of a form that are akin to each other. Mandelbrot introduced the word fractal as a general description for a large class of irregular objects, and highlighted the need for a fractal mathematics to be developed, or in some cases retrieved from isolated forgotten papers. Since the 1980s, fractals have attracted widespread interest. Virtually every area of science has been examined from a fractal viewpoint, with fractal geometry becoming a major area of mathematics, both as a subject of interest in its own right and as a tool for a wide range of applications. Fractals have also achieved a popular vogue, with attractive, highly colored fractal pictures appearing in magazines, books, and art exhibitions, and even used for scenery in science fiction films. Further public interest has been generated with the widespread use of computers at home and at school, enabling anyone with a basic knowledge of programming to generate intricate fractal pictures by repeatedly applying a simple operation. Of course, there is always a difference between idealized mathematical objects and the real phenomena that they may represent. A circle has a precise definition as those points on a piece of paper or other flat surface, whose distance from a center exactly equals a given radius, and a sphere consists of those points in space with the same property. We may refer to a coin or wheel as circular, and an orange or the earth as spherical, but these are only approximate descriptions. On close examination, the surface of an orange is dimpled and may be slightly flattened at the top and bottom, so it is not quite a sphere, and the Earth's surface is covered with hills and valleys. Nevertheless, in the right context, it is extremely useful to regard these objects as circles or spheres. If you want to calculate the number of oranges that can be packed into a box, it is good enough to assume that they are spherical. And when computing orbits of the Earth around the Sun or the Moon around the Earth, little is lost by assuming that these bodies are indeed spheres. In the same way, we define fractals in a mathematically exact manner, but we will also encounter natural, physical, and economic phenomena that can usefully be regarded as fractals when viewed over an appropriate range of scales. These will be thought of as real, as opposed to mathematical fractals, with the fractal description inevitably ceasing to be valid if they are examined too closely. This book contains pictures of various fractals, but they are no more than approximations to the exact